Yes, welcome to the exam guide section. Our question says that if z equals 1 plus root of 3I, determine its length. As you can see, this number is from complex numbers. So the solution would be for part A, Roman 1, the length, which is given by the magnitude of z, is, the formula is square root of x squared plus y squared. And what is x and y? We know that from complex numbers that is given by x plus I y. So the real part is going to be x and the imaginary coefficient of I is going to be y. So on substituting there, we shall see that x is 1 and then y is root of 3. This now implies that the complex number z's magnitude becomes square root of 1 squared plus square root of 3 squared, but they are all under root. Substituted for 1 as x, substituted for y as root of 3. This gives us what is 1 squared. It is 1. What is square root of 3 squared? It is 3. This gives us root of 4. Square root of 4. But since we are looking for the magnitude, this one gives us 2. So that is the length or the magnitude of that complex number. Part 2 is asking for the argument. Argument of z. What is an argument? Argument is the angle that the complex number makes with the positive x-axis. It is the angle that the complex number makes with the positive x-axis. And the best way that we can take the angle from the positive x-axis is for us to sketch this complex number on the Argand diagram. So on sketching it, I will have something like this. This is the real part of z. This is the imaginary z-axis or part of z. So if you look at our expression here, 1 is on the real part, 1 is on the real axis, so we have 1 here. And then root of 3 is on the imaginary axis, we put it there. And then we'll come and look for the point where they're meeting. They're meeting somewhere here. So you draw an arrow from the origin up to that point. You draw a line with an arrow on it. Why? Because a complex number is a vector quantity. It has the magnitude and it has the direction. So the argument that they are looking for is this angle here. So for us to solve that, we need to do something like that. We need to extract that triangle. It is a right angle triangle. It is in that format. This one like this, yeah, here, where this is the angle. From here up here is 1. From here up to root of 3 is the same as from the side of 1 up to the tip of that arrow. That means that it is also root of 3. How can we get this angle? Now we have the opposite to the angle and we have the adjacent to the angle. So we can use tan, because we know that tan of theta is opposite out of adjacent. That means now tan of theta here becomes, what is the opposite? It is root of 3 out of adjacent 1. So tan inverse theta now becomes an inverse of root of 3. And then you press your calculator. Tan inverse of root of 3 is 60 degrees. So this is the angle that the complex number z makes with the positive x-axis. Therefore, argument of z is simply 60 degrees. And then Part B says express the complex number z in polar form and represent it on the Argand diagram. We shall not repeat this, but this is the representation of the complex number on the Argand diagram. What we just need to substitute here is theta, which we have obtained here as 60 degrees. You put that angle there. But to represent it in the polar form, we know that the general representation of the polar form of complex number z is given by r into cosine of theta plus I sine of theta. What is r? Where r is the magnitude of the complex number z, which we have obtained already here as 2, and we have the angle here as 60. Now therefore the polar form becomes z equals to r, which is 2 into cosine of 60 degrees plus I sine of also 60 degrees. This is the polar form of this complex number. Thank you.